Hello and welcome back to Bluehat Cybersec Academy. In this lesson, I would explain the following. First, network design, then defense in depth. After that, zero trust, and network access control, which is also called NAC. And lastly, we will dive deep into network access control, or NAC. These topics are part of Domain 4. Network security concepts in the Certified in Cybersecurity exam and are useful for both exam preparation and building a strong cybersecurity foundation. So, let's begin. The objective of network design is to satisfy data communication requirements and achieve efficient overall performance. An important foundational concept in network design is network segmentation, which involves controlling traffic among networked devices. Complete or physical, network segmentation occurs when a network is isolated from all outside communications, so transactions can only occur between devices within the segmented network. Now let's look at a commonly used segmentation approach that allows limited external access. Demilitarized zone, or DMZ, is a network area that is designed to be accessed by outside visitors but is still isolated from the private network of the organization. The DMZ is often the host of public web, email, file, and other resource servers. With that covered, let's move further into logical segmentation techniques. Virtual Local Area Network, or VLAN. These are created by switches to logically segment a network without altering its physical topology. Another key technology that supports secure remote communication is the VPN. Virtual Private Network, or VPN, is a communication tunnel that provides point-to-point transmission of both authentication and data traffic over an untrusted network. Closely related to secure connectivity is access enforcement, which brings us to the next concept. Network access control, or NAC, is a concept of controlling access to an environment through strict adherence to and implementation of security policy. Now let's shift our focus to a broader security strategy known as defense in depth. Defense in depth uses a layered approach when designing the security posture of an organization. Think about a castle that holds the crown jewels. The jewels are placed in a vaulted chamber in a central location, watched over by security guards. The castle is built around the vault with additional layers of security, soldiers, walls, and a moat. In the same way, this approach applies when designing the logical security of a facility or system. Using layers of security will deter many attackers and encourage them to focus on other, easier targets. Defense in depth provides a starting point for considering all types of controls, administrative, technological, and physical, that empower insiders and operators to work together to protect their organization and its systems. To better understand this approach, let's look at some examples that further explain the concept of defense in depth. Data, controls that protect the actual data with technologies such as encryption, data leak prevention, identity and access management, and data controls. Application, controls that protect the application with technologies such as data leak prevention, application firewalls, and database monitors. Host, controls placed at the endpoint level, such as antivirus software, endpoint firewalls, configuration management, and patch management. Perimeter, controls that protect against unauthorized access to the network. This level includes technologies such as gateway firewalls, honeypots, malware analysis, and secure demilitarized zones, or DMZs. Internal network, controls that protect against uncontrolled data flow and user access across the organizational network. Relevant technologies include intrusion detection systems, intrusion prevention systems, internal firewalls, and network access controls. Physical, controls that provide physical barriers, such as locks, walls, and access control mechanisms. Policies, procedures, and awareness, administrative controls that reduce insider threats, both intentional and unintentional, and help identify risks as soon as they appear. Now, Let's move on to a modern security design philosophy known as zero trust. Zero trust networks are often micro-segmented networks, with firewalls at nearly every connecting point. Zero trust encapsulates information assets, the services that apply to them, and their associated security properties. This concept recognizes that once inside a traditional trust but verify environment, a user may have extensive freedom to move around, identify assets and systems, and potentially find exploitable vulnerabilities. Placing a greater number of firewalls or other security boundary control devices throughout the network increases the opportunities to detect a troublemaker before harm is done. Many enterprise architectures push this concept to the extreme by microsegmenting their internal networks, which enforces frequent reauthentication of a user ID. To better visualize this concept, consider a rock music concert. With traditional perimeter controls, such as firewalls, you show your ticket at the gate and then have free access to the venue, including backstage areas. In a zero-trust environment, additional checkpoints are added. Your identity is validated to access floor-level seats and again to access backstage areas. Your credentials must be valid at every level to meet the stars of the show. As a result, zero trust is an evolving design approach that recognizes that even the most robust access control systems have weaknesses. It adds defenses at the user, asset, and data levels, rather than relying solely on perimeter defense. In its most extreme form, it requires that every process or action a user attempts be authenticated and authorized, making the window of trust very small. While microsegmentation adds internal perimeters, zero trust focuses more on protecting assets and data directly, rather than building higher or additional walls. Next, let's take a closer look at network access control in more detail. An organization's network is one of its most critical assets. As such, it is vital to know and control access to it, both from insiders, such as employees and contractors, and outsiders, such as customers, partners, and vendors. Organizations must be able to see who and what is attempting to make a network connection. Historically, network access was limited to internal devices. Over time, this expanded to include remote connections, which were initially exceptions rather than the norm. This began to change significantly with the introduction of Bring Your Own Device, or BYOD, and the Internet of Things, or IoT. Focusing on IoT for a moment, it is important to understand the wide range of devices that may exist within an organization. These include heating, ventilation, and air conditioning systems that automatically regulate temperature, air monitoring systems, security systems, sensors, cameras, vending machines, and even coffee machines. A quick look around most environments reveals how widespread these devices have become. Once the need for a NAC solution is identified, the next step is understanding the capabilities it should provide. Everything begins with policy. The organization's access control and security policies must be enforced by NAC devices. It is important to remember that NAC enforces policy but does not create it. A NAC solution provides network visibility for access security and can later assist with incident response. In addition to identifying connections, it should isolate non-compliant devices within a quarantined network and provide mechanisms to remediate issues, such as enabling endpoint protection. In short, the goal is to ensure that all devices joining the network comply with organizational policies. This visibility applies to internal users, temporary users such as guests or contractors, and any devices they bring with them. To put this into context, let's consider some common use cases for NAC deployment: medical devices, IoT devices, BYOD, and mobile devices such as laptops, tablets, and smartphones, and guest users and contractors. It is critically important that all mobile devices, regardless of ownership, go through an onboarding process, ideally each time they connect to the network. Each device should be identified and evaluated to ensure compliance with organizational policies. Now let's dive a little deeper into how NAC works in practice. At its simplest level, network access control is a way to prevent unwanted devices from connecting to a network. Some NAC systems allow the installation of required software on an end user's device to enforce compliance with security policies. A high-level example of NAC in action is hotel internet access. When a guest connects to a hotel network, they are typically required to acknowledge the acceptable use policy before gaining internet access. Once acknowledged, the device is allowed onto the network. Some hotels add another layer by requiring a room number, guest name, or password. This helps prevent unauthorized use and may assist in tracking misuse to a specific user. A more complex example is a business environment that separates employee BYOD devices from corporate-owned devices. If a BYOD device is pre-approved, the NAC system can validate it using a hardware address or installed software and verify that antivirus and operating system updates are current before allowing network access. If the device is not approved for corporate access, it can be redirected to a guest network that provides internet access but restricts access to internal resources. That's all for now. Thanks for tuning in. Keep the momentum going by checking out the next video in this series, and if you haven't already, please like, share, and subscribe to Bluehat Cybersec Academy.